Okay, now we're going to look at number 12. So this next one, I'm going to read through it a couple of times. I know that there's some helps that kind of go along with it, but this one is a word problem where we need to set up a system, and then once we have the system of equations in place and that they're all in the standard form, then we can go to our calculator to get the solution more quickly. So what we're going to do here is we're going to figure out how many of each type of pizza was ordered. Okay, so this one has three different unknowns as they're asking for the number of cheese pizzas, the number of pepperoni, and the number of supreme pizzas. So when we read through this, I'm going to read through it a couple of times, but we're going to be looking for totals. It's one of the easy equations to write down in a system is if it gives you some kind of total. So let's read through this. Ben was in charge of ordering 35 pizzas for the office party. He ordered 3 types of pizza. That would be cheese, pepperoni, and supreme. The cheese pizzas cost $8 each. The pepperoni pizzas cost $10 each, and supremes cost $12 each. He spent exactly twice as much on the pepperoni pizzas as he did on the cheese pizzas. If Ben spent a total of $348 on pizza, how many pizzas of each type did he buy? All right, well, there's a lot of numbers in there. The ones that look like total numbers is the very first sentence where it says Ben was in charge of ordering 35 pizzas. And he broke that up into the 3 different toppings. Okay, and then they give us the price for each kind of topping. And then at the end, it said he spent a total of $348 on pizza. How many pizzas of each type did he buy? So right there, they're asking us for answers that are just how many pizzas. There's not anything about money, it's just how many of each type. So our variables are going to end up representing a count of each type of pizza. So I'm going to switch over here and look at the paper. We're going to start writing down some of our system here. All right, so you always want to look for totals when you're setting up one of these things. So this one's got, looks like 3 unknowns. I'm going to see, first of all, did they give us just how many of these pizzas we have to get? And it says, first sentence, it was in charge of ordering 35 pizzas. So yes, we have the total number of pizzas. All right, then hopefully, since this is something about how much something spent, how much money was spent in total on those pizzas, and that's in the very last sentence. It says Ben spent a total of $348 on pizzas. So that's dollars. Okay, so we could make a couple of pretty good equations out of that. Now, the only problem is there are 3 variables because there's 3 types of pizza. So let's define our variables right here so we're really clear when we read through it what each unknown is. So I'm just going to go in the order that they're mentioned and then the order it wants the answers, which is the number of cheese, pepperoni, supreme pizzas. So let X equal the number of cheese pizzas. So it's not about money, it's just about the number of pizzas. Y would be the number of pepperoni pizzas. And then Z, the most expensive ones, were the supreme pizzas. I'm going to also kind of make a note out here to the side what they cost, since I have my screen up in front of me. The cheese pizzas cost $8 each. Pepperoni was $10 each. And the supremes were $12 each. That's just going to help later when we set up an equation. All right, so equation 1, let's just count up the pizzas, number of pizzas. So when you're setting up a system, if it's got differently priced items that you're trying to combine, at different prices, one of them should just be about counting everything up, no money involved. So these things right here are just counting the pizzas. So those 35 pizzas were broken up into this many of each type of pizza. But this is always kind of an easy one to set up where you're just counting up the total number of those items. Okay, X plus Y plus Z. The next one that's also pretty easy is the money spent or total value, kind of depends on the wording. So the money spent in this case, well, this is how many cheese pizzas. X is the number of cheese pizzas. We now know that the cheese pizzas cost us $8 for each pizza. So I'm just making up as an example, if I ordered 10 cheese pizzas, I'd have spent $80, right? Because $8 times however many pizzas. I just don't know what this number is, so it's going to be 8 times X. $8 per pizza times X number of cheese pizzas. And we're going to do the same thing for all of them. Every one of them is price times amount, price times amount, price times amount equals total. So the Y represents the pepperoni pizzas. That price was $10. So I spent $10 times however many pepperoni pizzas. I can put little dollar signs here to kind of emphasize what I'm doing. And then the Supreme pizzas cost $12 each. So I would have spent $12 times however many Supreme pizzas on Supreme pizzas. And altogether, that totaled up to $348. So total number of pizzas, X plus Y plus Z. Total amount spent on the pizzas is the individual pizza price times that variable for all three types of pizzas. Okay, if we were in a two-variable system, we'd be good to go. We could move to the solving stage, but we have three variables and we only have two equations, so we do not have enough information to solve for the variables unless we come up with a third equation. So this is where we have that weird wording, spent twice as much on pepperoni pizzas. I'll write this down. He spent, sorry, twice as much. It's weird wording, which is why I wanted to kind of talk through this sentence. He spent twice as much on pepperoni pizzas as he did on the cheese pizzas. This particular sentence is kind of written in kind of slang conversational English. It doesn't have a structure that can be directly translated into algebraic symbols. Oh, sorry, let me get this up where you can see what I'm doing here. Like that. There we go. Okay. So let's first of all talk about again how much was spent on pepperoni pizzas. So we do on pepperoni pizzas. Let me pull this from the thing above here. Remember, this was cheese, this is pepperoni, this is Supreme as far as the columns go. So this right here is how much was spent on cheese. This is how much was spent on pepperoni. So when it says pepperoni pizzas, the total spent was $10 per pizza times Y. The amount spent on cheese pizzas was the individual cost of a cheese pizza, which was $8 times X, which is the number of cheese pizzas. This represents how much was spent on those two types of pizzas. 10Y is how much was on pepperoni, 8X is how much was on cheese. And they give us a comparison between the two. It just says he spent twice as much on pepperoni as he did on the cheese pizzas. Okay, so that makes sense because the pepperoni pizzas are a little bit more expensive. Plus usually the pepperoni pizzas are the first to go when you do a pizza party. All right, so be careful of we want to make an equation, so we want to set these things equal. Okay, so remember again, if that means we spent $40 on cheese pizzas, then we must have spent $80 on pepperoni pizzas because that's twice as much as what's on the cheese pizza. So think about if I wanted to make these equal. All right, here's pepperoni on this side, here's cheese on this side. If I want to make them equal, again, pepperoni, cheese. All right, these are not equal, right? These are more expensive, these are less expensive. So if I want to make them equal, I have to adjust one side or the other to make them equal. So even though I know the word twice is close to pepperoni, twice as much on pepperoni as he did on the cheese pizzas, you could reword this to say the amount that he spent on pepperoni pizzas was twice the amount he spent on cheese pizzas. In other words, this is the smaller amount, so to make them equal, you're going to have to double the smaller side. So it doesn't look right, but I mean, that's what it says. It says this is the more expensive one, this was the less expensive one. If I double this, then they're equal. Then that says the pepperoni is twice the other one, spent twice as much on the other. Okay, so let me simplify this and say 10Y equals 16X. This is my third equation. However, before I write it in up here, I want to make sure that, let's scooch this down here. I want to make sure before I put it in up here that it's in the correct form. So this is comes from the wording, the description on the weird relationship between pepperoni and cheese, but I want to rearrange the terms so that I have the X term first, I want to have the Y term second, I want to have the Z term third, I want to have equals, and then I want to have the constant term. This is how you set up the terms for standard form on a 3-variable system. If we don't have any of these terms, we use 0. Okay, so first thing is all the variables on one side. So I've got to move the 16x over to the other side. So it's going to say negative 16x, and then I have the y term, 10y. I don't have a z term, so I'm just going to use 0. That means I had 0 z terms. There also isn't a constant term. So again, 0. Sorry, I keep forgetting that I haven't pushed it up here. So again, I'm moving the 16 to the other side. That's where it is here. The 10y was already on the left. I don't have a z term, so I'm saying I don't have any z terms. Don't have a constant term, so don't have a constant term. This is my third equation in the standard form. Okay, so it looks a lot more fancy than just the amount of money spent on pepperoni pizzas is twice the amount of money spent on the cheese pizzas, and then rearrange it. So let me go back and fill it in as my third equation here, now that I've got it rearranged. So negative 16x plus the 10y plus 0z equals 0. So on this one, the first two equations are easy. Count up the total number of everything and just add your letters together to equal the total. The second one is the total money. You have to take the price times the amount of each individual type of item, make it equal the total amount. And then you have to be really careful on this one to figure out which side got doubled. Okay, we have to double the cheese pizzas to make it equal to pepperoni. So that's where the 16x came from. Then we had to move it over here. All right, so now that we have this, we're going to go to our calculators and we're going to put this in as the augmented matrix on our calculator, just like this. Our terms are in the right order, so my top equation, we just pull off the coefficients. 1x, 1y, 1z. 1x, 1y, 1z equals 35. This is how you do an augmented matrix. Put a little line. This is just when you're writing it out in paper. The line shows you where the equal sign is. Everything to the left of the line represents variables, and then your final column over here is your constant column. All right, so our middle equation says 8x plus 10y plus 12z. That's 12z equals that total number, dollar amount. And then the bottom one was negative 16x plus 10y, no z's, no constant. So this is the 3x4 matrix that I'm now going to put into my calculator and let the calculator do the rest of the heavy work. So here we go to the calculator look. Where are we? Calculator right there. All right, so I'm going to go to my matrix. I still have the right dimensions as I did before, so I'm just going to go over to edit and just change over to the new values. I'm going to just click through here and get to the first row. All right, so here's what I want to do, the 1, 1, 1, 35, and so on. So middle one was the prices, 8, 10, 12, and the total amount of money. And then the last one was the kind of bizarre looking negative 16x. And then we have 10y, no z's, no constant. Okay, so I'm double checking it just to make sure I don't have any typos here. Okay. So once you have the system correctly assembled, then it's very easy from here on out. You go and put the matrix into your calculator, and then we're going to go back to the main screen and do that same RREF command we did before. It's just now we have different values in those rows. So when I do the RREF command this time, this part's going to stay the same, but these numbers on the right are going to change because now we're counting at pizzas. They should add up to 35 when we get down here. So let's do the command. It's matrix. It's a math command. I'm just going to click up this time to show you how it's faster. See, it's right there on the bottom, RREF. It's not too many clicks up. So RREF, reduced row echelon form, that creates all the ones and the zeros. We want to tell it matrix A again, matrix. Stay in the first column and just select the name. I don't think you necessarily have to close your parentheses, but see how this looks the same? Again, this is saying X equals 10. So remember, this means the number of cheese pizzas was 10. The number of pepperoni pizzas was 16. The number of supremes was 9. So that is the answer to the question. So we had 10 cheese, 16 pepperoni, and 9 supreme pizzas. X is 10, Y is 16, Z is 9. Okay, so